Folks, welcome back. We're going to do some more molecular, ionic, and net ionic equations, and we're going to practice using our solubility rules as we do that. So let's jump right into an example. Let's do example 15 together, then I'll have you do example 16. Without my help, we'll see how you do. So we have potassium carbonate and calcium bromide. So let's see, potassium is K+, carbonate is one of your polyatomics. It's CO3 negative, so we have K2CO3. All potassium compounds are soluble, so I'll put AQ after that. And calcium bromide, calcium's in group 2, it's 2 positive. Bromide comes from bromine, which is in group 17, it's 1 negative. So that's CaBr2. And if you use your solubility rules, all chlorides, bromides, and iodides are soluble except silver, mercury, and lead, and calcium's not one of those. All right, now these are double replacement reactions. So potassium will get together with bromide. So we end up with KBr. That's the result of a 1 positive and 1 negative ion coming together. We'll leave our parentheses blank for just a second. We'll look up that solubility rule. And calcium is going to get together with carbonate. Calcium's 2 plus, carbonate's 2 negative, so we'll make CaCO3. Now, let's fill in these parentheses using our solubility rules, KBr. So, if I go back a page, looks like all potassium compounds are soluble, no exceptions to that rule. So that's the one I'll use. We'll put AQ after that one. Potassium bromide we'd expect to dissolve in water. And now let's look up a rule for carbonates. That's also on the previous page. So let's see, carbonates, it's right here. They're insoluble except for group 1 and ammonium. So let's see, who is it with? Carbonates with calcium. It's not in group 1 and it's not ammonium. So that would be a solid that would precipitate out. Now let's balance this molecular equation. Looks like I need 2 potassiums and 2 bromides on the product side, so I'll put a 2 there to balance that. Now let's write this ionically. Okay, so when potassium carbonate is dissolved in water, won't I get 2 potassium ions surrounded by water molecules and a carbonate ion surrounded by water molecules? Calcium bromide, AQ, I have a calcium ion surrounded by water and 2 bromides surrounded by water. CaBr2 gives me a calcium and 2 Br negatives. On the product side, I have 2 KBrs, AQ, so I have 2 K pluses surrounded by water and 2 Br negatives, AQ. And then calcium carbonate, I am not going to separate. They're more attracted to each other than they are to water, so they precipitate out. So this is my balanced ionic equation. Now let's cancel out my spectator ions. So when I do that, let's see what's the same on both sides. 2 Br negatives are the same, and my 2 K pluses are the same. Yeah. So now we can write our net ionic. So for the net ionic, I like to write the positives first. So I have Ca2 plus, AQ left over, CO3 2 negatives, AQ, and I make CaCO3 solid. So there's my molecular, ionic, and net ionic equation for example 15. Now, why don't you try example 16 without my help, and then come back to the video and we'll see how you did. All right, so welcome back. We have copper 2 sulfate and barium nitrate. Copper 2 is Cu2 plus. Sulfate is one of our polyatomics, SO4 2 negative. So we have CuSO4. Sulfates are soluble. There are some exceptions, but copper is not one of them. So we'll put an AQ after that. And barium nitrate. Barium is 2 plus. It's in group 2. Nitrate's a polyatomic. It's NO3, 1 negative. So that's Ba parentheses NO3, and we need 2 of those. And of course, nitrates are all soluble. So we'll put an AQ after that. Okay, double replacement. So the copper will get together with the nitrate. So copper's 2 plus and nitrate's 1 negative, so that's CuNO3, 2. I'll leave the parentheses blank for just a moment. And then barium gets together with sulfate. Barium's 2 plus and sulfate's 2 negative, so that's BaSO4. All right, let's check our solubility rules. Let's check the nitrate rule for copper 2 nitrate. So we're going to have to go back a page. This is a rule you probably become pretty familiar with. Here's my nitrates. All nitrates are soluble, and there are no exceptions to that. So we'll put an AQ after that one. Okay, now my sulfate rule. Let's look that one up. So my sulfate rule, that one has a lot of exceptions. Here's my sulfate. Most are soluble except calcium, strontium, barium sulfate, silver, mercury, and lead. So barium sulfate is not soluble. So that means we're going to put an S after that. It will form a precipitate when I mix those two solutions together. All right, let's make sure this is balanced. 2 nitrates on both sides. Yeah, that's balanced as it's written. So let's write the ionic equation. Did you put Cu 2 plus AQ and SO4 2 negative AQ? And we have barium nitrate AQ, so that's Ba2 plus AQ. And we're going to get 2 nitrates out of that, aren't we? Because it's BaNO3, 2. Okay, reacts to form Cu2 plus AQ and 2 nitrates AQ and BaSO4 solid. Those are more attracted to each other than they are to water molecules. So now we can cancel out our spectator ions. So let's start doing that. What do we have? These 2 nitrates are gone. Anything else? Yeah, those two, the copper 2 pluses are gone. So we have Ba2 plus and SO4 2 negative makes BaSO4 that remain. So let's go ahead and write that. Ba2 plus AQ and SO4 2 negative AQ react to form BaSO4 solid. And there you have it, your molecular, ionic, and net ionic. How did you do? Did you get it right? All right, well, that's all right. If you messed up, that's okay. We have another one to practice on. Please do example 17. So take a couple of minutes, go as far as you can on example 17, then come back to the video, and we'll see how you did. Alrighty, welcome back. Hopefully you're getting used to these. Chromium 3 iodide and ammonium acetate. So chromium 3 is Cr3 plus. Iodide, that comes from group 17, it's I negative 1. So we have Cri3, and iodides are soluble except for silver, mercury, and lead. Chromium is not one of those exceptions, so that's soluble. Put an AQ after it. And ammonium acetate. Ammonium is a positive polyatomic ion, NH4+, and acetate C2H3O2 1 negative. So we end up with NH4 C2H3O2, and that is also AQ. All ammoniums are soluble, and acetates are. No exceptions. All right, so chromium will be together with acetate. So chromium's 3 positive, acetate's 1 negative, so that's Cr parentheses C2H3O2 3. Leave our parentheses blank for just a sec. And ammonium will get together with iodide. NH4 is positive 1, I is negative 1. And we'll leave our parentheses blank for just a sec. So let's look up the solubility rules for acetate first. So we'll go to the previous page and find acetates. Here it is, acetate. All acetates are soluble and no exceptions. So that'll be an AQ after that one. And how about ammonium iodide? Let's look up our rule for ammonium here. And ammonium, right there, so the positive sign's missing. They are soluble and also no exceptions. So that one also will dissolve in water, AQ. Alrighty, so let's go ahead and write our ionic equation. Oh, let's balance it first. 1 chromium, 3 acetates, we got to put a 3 there. 3 iodides, need to put a 3 here to give me 3 iodines. And yeah, that takes care of it. So a 3 there and a 3 there. All right, so ionically, we have Cr3 plus AQ and 3 I negatives, AQ. We have 3 ammoniums, so 3 NH4 pluses, AQ. We also have 3 acetates, so 3 C2H3O2 negatives, AQ. All right, they react to form chromium 3 acetate, which is AQ. So we have chromium 3 plus dissolved in water and 3 acetates dissolved in water. We have 3 ammoniums and 3 iodides also. So 3 NH4 pluses, AQ, and 3 iodides, AQ. All right, so let's go ahead and cancel out our spectators. Looks like we have a lot of those this time. So here we go. Chromium 3 plus is gone. My 3 iodides are gone. My 3 ammoniums are gone. And my 3 acetates are gone. Everything is gone. So when everything cancels, we end up with no reaction taking place. So what we write here would be the letters NR for no reaction. Nothing will happen there. We'll mix those two solutions together and we'll end up with a solution. None of the ions will combine with each other. So every once in a while you'll have a no reaction on your example problems. Okay? All right, this bottom part of the page is sort of a recap of molecular ionics and net ionics. This one's barium nitrate and sodium carbonate. And barium gets together with carbonate and sodium gets together with nitrate. And you can see how we did that. We balanced it by putting a 2 there. Then we wrote the ionic equation right down here. Then we canceled out the spectator ions right down here. And we were left with our net ionic. So there's another example for you folks to look at. So in your upcoming assignment, I think we do about 10 of these. And then we have a lab where we do 50 of these. So you'll get pretty good at writing these types of equations. You'll also get good at learning your solubility rules. Alrighty, thanks for tuning in. See you in class soon. Bye-bye.